Hello everyone, I'm Jay Surya of 2nd BTech ADS branch, second year. Now I'm going to explain what is closure in JavaScript. Before understanding what is closure, we need to know scope. There are two types of scopes in JavaScript, that is global scope and local scope. Global scope means variables declared outside of any functions or accessible everywhere in your code. That means the variable outside of a function can be accessible from anywhere of the code. Local scope means if the variables are defined in a function, then it can be accessible only inside the function. If we go outside the function and if we want to access that variable, we can't do that. So let's see an example. Let global variable equal to I am global. We have assigned a string I am global to the variable. So in the function local scope example, we have assigned uh, I am local string to the local variable, which is defined in this function. So if we try to access the global variable, it can be accessible, and also local variable that is which is inside the function. But once we go outside the function scope and if we try to access the global variable, still we can access the global variable. So we'll get the output as I am global. But outside the function, if we try to print the local variable, we get local variable is not defined, which means we can't access the variable which is defined inside a function. So global variable is accessible from everywhere. Global local variable is accessible to local scope example only. Now let's understand what is closure. Closure is a feature in JavaScript where a function remembers the variable from its surrounding scope where it was created. In simpler terms, we can say a function can access variables that were declared outside of it even after the outside function has finished its running. Why is closure very important? Closures are powerful because they allow data encapsulation, keeping the variables private, and state persistence, which means remembering the state of the variable between the function calls. Let us see an example to understand this closure. So we can see here a function is defined outer function. Inside it there is a variable called count which has been assigned 0 value to it, and there is another function inside inner function name inside it, and in that inner function we are updating the count and we are printing the count, and from the outer function we are returning the inner function. So when we assign the outer function or when we call outer function through a variable myClosure, so every time we call the function myClosure, the value of the count equal to 0 1 at the starting of the call it's used. So when we call the first time outer function, the value is 0, but when we call the function second time, the count will be updated from 0 to 1. Here again the value won't be reset to 0. So here the value is 1. When we call the myClosure function again, generally we think that the value will be reset to 0. So again the value will be 1, but it's wrong, because here for every closure call it won't access the other variable. Here here there is no count variable defined here. The count that we written there here uh, stores the value of the its previous value. So it knows that its previous value is 1, so it will update it to 2. Similarly, for the third call also it will be incremented by 1, so output will be 3. Inner function remembers the variable count even after the outer function has finished running. This is because of the closure. Let us understand step by step. First we have defined an outer function, where outer function is the function that we define, and inside outer function we declared a variable count and initialized it to 0. count is local to outer function. This means it can be only accessed inside the outer function or by other function defined within it. And we know that this variable is important because it will be remembered by a closure. And the second step is we will define the inner function inside the outer function. So inside outer function we define another function called inner function. Inner function we have increments the count variable by count plus plus. This increases the value of the count by 1 each time we call it, and it prints the value of the count through console.log. And step 3, it returns the inner function from the outer function. And step 4, call outer function. Here we call outer function and store its returned value in a variable called myClosure. At this point, the execution of the outer function is completed. The variable count from outer function is no longer directly accessible. However, because of the closure, the inner function still remembers the count variable. So every time that we call myClosure multiple times, it will remember its previous value and it will increment by 1, but not reset to 0. So when we call myClosure for the first time, it executes the inner function that was written by the outer function. Inside inner function, the count variable is incremented by 1. Now count equal to 1. The new value of the count is 1. So for the second time when we call myClosure function, it will print 2. For third call, it will print 3. So in general terminology, let's understand. Imagine you have a locker, which is also count, inside a room called outer function. When you leave the room, you give someone inner function or the key to the locker, right? Even after the room is locked, the person can still use the key to access and modify the contents of the locker. In the same way, once the variable is created in the outer function, and by using closures, we can remember its previous value and we can modify it without resetting. And here we can see the second example for the closure, which helps how it shows how it gives data privacy. So let's come to callbacks, promises, and async pivot. These are the important concepts in JavaScript that helps in backend. A callback is a function passed as an argument to another function. It executed after the first function completes its tasks. So let's understand the example. So we have a function fetch data, which have an argument callback, and it has something logic here, console printing the data, fetching data, and there is another function set timeout, and we are calling the callback and sending the data loaded in it, and it will be called continuously for every 2000 milliseconds or 2 seconds. And there is another function display data, which accepts an argument data and prints it. So we are passing display data function as an argument to the fetch data function. So it will store the display data function in callback here, and after that it will print first fetching data on the screen. After that there is set timeout function. So after 2 seconds it will print. Here we are calling callback after 2 seconds. So when we call callback, which means nothing but display data, which we store here. So data loaded information is sent to data. It will accept it and it will print. So we are calling display data from fetch data function after 2 seconds. So this is callback. After finishing task of one function, it will call another function. This is callback. So fetch data accepts a callback function, display data. Once the stimulated data after 2 seconds is over, it displays the displayed data. Problem with the callbacks. The most important problem is callback help, which means if for 1 or 2 or 3 functions, it's okay to call one function from another function. But if the number of functions increased, we lost the track of which function is calling which one. It will causes callback hell. The problem is called as callback hell. When callbacks are nested, the code becomes difficulty to read and maintain and to understand. Let's say an example. Function step 1. Here the function is step 1 and it is accepting the argument next in it. Here it will first print the step 1 and after 1 second it will call another function. So in the same way, 3 functions. So we are calling step 1 and passing step 2 as an argument, in which step 3 is passed as an argument to step 2. So it will cause a hell which is called as callback hell. It's very difficult to understand. Promises. A promises is an object that represents a future value it can be, which means it will give the output of the a function. Like there are 3 certain possibilities for it, either pending or fulfilled or rejected. When we give a task to the backend or when we start a task, we can get possible 3 values as an output, either pending or fulfilled or rejected. Pending means the promise is still in progress, fulfilled means the task is success, rejected means the task is failed. So there is a function called fetch data, and promises are the better alternative for the callbacks. So fetch data, a function is there and we are returning new promise. Here we will pass resolve and reject as arguments to the promise. So we are printing fetching data and we are calling another function. If the if the execution of the fetch data function is success, then only it will call the other function, or it will reject it. So based upon the output of the first function, it will call the second function. It won't cause any uncertainty. So if fetch data is success, then it will print data loaded, which means it calls other function. But if the data if the function is failed, then it will print failed to load the data. So resolve is called when the task is successful, reject is called when the task fails. Dot then handles success and dot catch handles errors. In some cases even promises also fails. So in such cases when we don't want the one function to wait for the other function to complete, instead to run simultaneously, we use async await. Async await is a cleaner way to work with asynchronous code. It is built on the top of promises but looks more like synchronous code. So again we have the function fetch data and there is a new promise, resolve and reject. So here we're printing fetch data. Once it gets successful, it will call a resolve function where it has the argument as data loaded. So we have an asynchronous function data load data function, and we are passing start as a printing start, and we can see here we are assigning fetch data function to a variable called data. And so once it will executing the code, it will print the start, and after when it sees await, it will stop the execution of the remaining code, and it will wait for the completion of fetch data function. If all the code in this fetch data function is completed, then only it will move to the other lines of the code in load data function. So till then it will await for the fetch data function to complete. So it will wait for the promise to resolve, and after that once this function is resolved or it completes successfully, then only it will print the data, and it will print end. So we are calling the load data function. At least we have to call once for the execution of the function, right? So await pauses the function until the promise resolves. The code is easier to read than nested callbacks or dot then chains. Until now we have understand the basic concept that we need to implement a to-do list. So let's implement a to-do list using closures. Here is how we can use closure to create a simple to-do list. First, we have created a function create to-do list, in which we have assigned an empty array to variable called tasks, and we are returning an object add task function. So can you see here the logic? And using closures, we will implement this to-do list. And there are even better ways to do this, but we have seen how to implement to create a to-do list project using closures.